what has happened in the last class, that is how to draw an ellipse on the drawing sheet. Okay, so once again I would like to repeat, because the same procedure you have to adapt for the rest of uh, uh, curves like parabola and hyperbola. Even there is a one more special curve, rectangular hyperbola. All the same procedure, small modification. One step is little bit different compared to the remaining steps are almost same. So I would like to share my screen and I will show. In the last class we have seen how to draw an ellipse. Okay, and again using the same step-by-step procedure, we have to draw the parabola and hyperbola. That's why I'm repeating the topic. Just remember, the problem will be like this: construct. Are you able to see the screen?
Yes, sir.
Yeah, construct an ellipse when the distance of the focus from the directrix is equal to 50 mm and eccentricity 2 by 3. As you know, ellipse eccentricity is always less than 1. It can be 2 by 3, 3 by 4, etc. Okay, now here importantly, you are given focus distance, the focal point F, capital F distance 50 mm from the directrix. As you know, horizontal line is a axis, right? And this vertical line perpendicular to the axis, we call it as some AB. Okay, and this is C axis, and this is AB directrix, right? First important step is locate the focus on the axis. Okay, after locating focus point, divide this focal distance into a number of equal parts. A number of equal parts depending upon the eccentricity ratio, 2 by 3. Numerator is 2, denominator 3. You add 2 plus 3, that is going to be the required number of parts to be divided. Okay, uh, the the CF length is the distance. We need to divide the CF length into 5 equal parts only. Okay, if it is in case the ratio is 3 by 4, okay, you can take 3 plus 4, 7 parts here. And we discussed already how to divide CF into a number of equal parts by line division method, by using mini drafter, how to draw parallel lines, how to divide okay, the given length into a number of equal parts. After that, how to locate the vertex we have learned, right? So the vertex point is always two parts, not always. In this problem, 2 by 3, numerator parts, two parts. We need to move from focus. Okay, so locate that vertex. Okay, suppose there is a problem 3 by 4, you have divided 7 parts, right? At the time 3 is the numerator. 3, so you take 3 parts away from the focus. Okay, by doing so, what you are doing is basically 2 is the numerator parts and 3, that is we are leaving 3 parts to the left hand side of vertex from the directrix and 2 parts from the focus. I will explain in detail already, okay, in the previous class, how the properties of an ellipse will be, what is the concept of eccentricity, everything we have learned, right? Now just I am explaining how to draw the ellipse on the drawing sheet. Okay, after locating B, okay, two parts from focus, take BF is equal to BE. With your compass you can measure the distance BF, that must be equal to BE. Join CE, extend that line further with the help of drafter, or you can use ordinary scale. Okay, the next important step is you can select a number of random points, okay, after vertex like this, and these random points can be equidistant or unequal distances. Okay, you can choose 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. Since it's a closed curve, till the curve closes, we need to take a number of random points. Okay, so I have taken after vertex 1, 2, 3, 2 here matching with the focus, need not be matching with the focus. You can select this point to after focus or before focus, no issue. I said there is no standard rule that we need to take equal distant points. Okay, you can choose anywhere. If you are interested to take equidistant points, you can also take like this. Okay, so 1 2 3 4, after taking draw perpendiculars, okay, lines to the axis, then automatically these lines will meet the inclined line already you have extended, right? So at different points, 1 2 3 dash 4 dash, something like that. Okay, after vertex we have already taken one, so along the same line you call it as 1 dash, 2 2 dash, like that. And we come to the end of the problem, right? Then you have to take the compass, measure the radius 1 1 dash with your compass. That is the radius of the first radius of the first two arcs. Okay, take focus is the center of your compass all the time, okay, throughout this problem. But radius is changing from 1 1 dash to 2 dash 3 3 dash, okay, like that. So initially you take 1 1 dash is your first radius of your compass. Focus is always the center. Cut the first line above and below the axis, you will get the two arcs like this. That means 2 points we have generated. 2 points, okay. Already vertex point is there, so vertex is the starting point of the curve, okay, elliptical curve. So on the line 1 1 dash above and below we have drawn two arcs with radius 1 1 dash. 1 dash is all on the inclined line, remember. So 1 1 dash is having some radius. We are taking the center of the compass at F. Cut the line above and below, you will get 2 points. Okay, you repeat the procedure, you will get so many other points. Second radius is 2 2 dash, focus is the center, you will get two more arcs. 3 3 dash is the radius, focus is the center, cut the third line. Automatically you can generate a number of equal points, a number of arcs, and we call them as generating points. Okay, with help of HB pencil now. HB. Take HB pencil, join all these generated points with smooth curve. Okay, that is known as ellipse. Okay, so you can also draw normal and tangent. You take any point here, any point on the ellipse. So you take. I have taken this point, and I have joined that point to focus. Remember, whenever you take any point on the ellipse, okay, this red color curve I have taken, that is known as elliptical curve. Use HB pencil, black and white only on your drawing sheet. Okay, so after joining this point to the focus, you need to draw one 90 degrees line to this already drawn line with help of mini drafter. Easy way to draw perpendicular is with the help of mini drafter. After after drawing perpendicular, it will meet the directrix at point T, capital T. Join the T point to the selected point on the curve. That is going to be your tangent. Tangent is always away from the curve, right? Tangentially just touch the curve outside. And if you draw normal, if you want to draw normal, what you have to do? Draw one perpendicular to the tangent from the point we have selected. Okay, so this normal tangent drawing is a common procedure for even parabola and hyperbola. So is this clear? Then I will move forward to explain parabola or hyperbola. Then you will practice on your drawing sheets. Any other question in this particular topic?
No, sir.
Okay. Shall I move to draw? I will explain how to draw hyperbola. Okay. Then I will give you assignment homework. Okay. You will draw the parabola. Okay. So I will share one more problem. I will explain how to draw hyperbola. Am I clear? Am I visible to you? The
Yes,
screen?
sir. Yes. Sir, can you share the previous also with us, sir?
1 minute. Yeah, please.
Can you share the with us?
Not clear. Your voice is not clear.
Can you share the videos with us, sir? This problem?
You need video lectures.
No, no, no. I'm telling you, will you share these problems with us? These videos which you're showing us now, will you share it in Newton? I'm asking, sir.
Acha, okay. See,
Yes, sir.
yeah, actually, I have edited, okay, some online videos so that
Okay, sir.
whatever important to you, I am just sharing. I think this particular at the end of this class, you will get automatically what I have explained. Okay, don't worry
Yes.
about the video I am sharing or
Okay.
PPT. Okay, you need not worry because a lot of information is there in the online. Okay, if you want to dig it out, okay, it takes more time for you. So we have
Yes,
done
sir.
all that necessary work. Okay, whatever
Okay,
is
sir.
important to you, okay, that is we are sharing some important videos. So everything is free, right? Nothing wrong. I can use my videos or PPTs from internet. Okay,
Yes,
so
sir.
these are all free open source material. So I've already edited a lot of lengthy videos. So you need not require all the lengthy videos.
Okay, sir.
Okay,
Okay,
whatever is
sir.
important, just I am showing you. These videos, whatever I am sharing important steps, you can directly watch from Newton because
Yes,
these
sir.
yeah these lectures are automatically posted to your Newton. That is sufficient. Okay, don't worry
Yes.
about complete lecture. Okay,
Okay, sir.
yeah. So construction and hyperbola when the distance of the focus from the directrix is equal to 50 mm and eccentricity is uh, 3 by 2. Okay. Now, what is the data given is almost similar to the an ellipse, right? So here again I have given 50 mm, but it can be 54, 53, whatever it may be. Okay, eccentricity, as you know, hyperbola it is greater than 1, that you have to remember. Okay, ellipse less than 1, hyperbola greater than 1. What is the eccentricity of a parabola?
One.
Equal to, exactly equal to 1. Okay, that parabola you have to draw on your own. Just listen this problem also. Okay, and there are three practice problems with that you need to complete by the next class. Okay, so that you will get some internal assessment marks. Okay, so one only one parabola problem only I will give you as assignment. Remaining two problems I am explaining here, you can draw along with me, and all together you can post in Newton, what can I say, that Google Classroom. Already I have posted that at assignment for both the sections I am dealing. Okay, you can directly use that link and you can simply upload the uh, figures. So whatever you are drawing on the drawing sheet, take a pic, okay, with your phone and send it as PDF or JPEG, okay, and submit that as an assignment. Okay, and don't forget that write your roll number, name, section on the every page of your photograph. Okay, while taking photograph itself, you write, you take a photograph such a way that that covers your roll number, name on the drawing sheet. Okay, okay, now the procedure is almost same. Hyperbola, first we need to draw one axis line like this and a directrix line. Then you need to locate the focus at 50 mm distant from the directrix on the axis with help of ordinary scale or mini drafter scale. Remember, while drawing axis, use the longer scale of your mini drafter. Just tight the knob, mini drafter knob, and automatically the other scale is the directrix only, right? So don't disturb the drafter. Don't disturb the drafter. Whenever you want to draw perpendicular lines to the axis, use the AB directrix as reference and try to match your mini drafter scale to the AB and draw perpendiculars. Okay, so that is the advantage of mini drafter, to draw perpendicular lines or parallel lines. Okay, mini draft is very useful. So start with mini drafter, scale, you draw one horizontal line, just tight your mini drafter knob. Okay, so then you can easily draw the, because other scale is 90 degrees to the longer scale is 90 degrees to the shorter scale. So mini drafter is in the form of L shape, right? So you can use the advantage of mini drafter. Then already given eccentricity 3 by 2. Okay, add 3 plus 2, 5. 5 is the number of parts to be divided. Okay, the distance CF. Okay, then how to divide CF into n number of equal parts? You know that line division method. You need to draw one inclined line, draw on it five equal arcs, right? Join the last arc to the focus, draw parallel lines. Okay, that is the procedure I explained earlier, right? Do you have any doubt in that line division method?
No, sir.
Okay, then after dividing, just I am not showing the line division method here, but you need to show with the 2H pencil. So anyway, all these lines till now, at the end of the problem, only we will use HB pencil. All other lines, generally construction lines, known as construction lines, used with the 2H pencil only. Then look at vertex. I said already. Numerator you need to remember. Numerator 3, right? 3 by 2. 2 is the denominator, 3 is the numerator. These three numerator parts we need to move from focus. That is that you have to understand. So or else you can remember it in this way. Denominator parts you need to leave from the directrix. Okay, anything you can remember. So I suggest you remember the numerator parts 3. So move from 3 parts from the focus, that is going to be your vertex. Okay, then the next step is, already you know that, right? Vf must be equal to v. Vf must be equal to v. Then draw one perpendicular ve such that the distance vf is equal to v. Next step is ce extension line. You need to join ce, that should be extended. And after vertex point, what I said, after vertex point, you can select any number of random points, 1, 2, 3, 4, 5, 6. So here by default, the third point is matching with focus. That need not be mandatory. Okay, you can choose these points. Okay, randomly anywhere. May not be equal in distance. Okay, 1, 2, 2, 3 may not be equidistant. Okay, that you need to remember. So I have selected already existing points 1, 2, and 3. Okay, and after that also I have taken 3 more points. Remember, ellipse is a closed one, but parabola is an open curve. So I can take maximum of 6 or 7 points, not more than that, not required actually. Okay. Thereafter, what is the procedure now? You compare only the VF distance is increased, okay, compared to the previous ellipse problem. Otherwise, the rest of the procedure is same. In the ellipse case, we have taken n number of more points, 10 points, 13 points, because it's a closed one. We need to close the curve. So we have taken more number of points here compared to the ellipse. Here only we have taken only 6 points. Okay, 6 or 7 you can take, no issue. Okay, then already we have taken this extension line. We have drawn so many perpendiculars, right? So simply you can locate 1 1 dash, 2 2 dash, 3 3 dash. Okay, there is no procedural differences except locating the vertex. That is very important. That concept even applicable for parabola. That is the assignment problem you supposed to draw on your own. Okay, I don't want to explain that one. Okay, so ellipse I explained. Now hyperbola I am explaining is only a major difference is the location of vertex. I have to leave three parts from the focus, okay, and the same distance, three parts distance with compass I have to take, and I have to draw one perpendicular here. Then I have to extend C. After vertex, I have to take a number of random points. Need not be the equal distance. 1, 2, 3, 4, 5, 6 perpendiculars. From there, those lines will meet inclined line, extension line at 1 dash, 2 dash, 3 dash, and so on. Then you take your compass. This is the last step. Okay, take your compass. First radius is 1 dash. Focus is always the center of your compass while drawing the arcs. Okay, so I have taken 1 dash radius focus center. I need to cut the 1 dash line above and below the axis. Okay, so you can able to see here. Okay, similarly I have to take 2 dash is the second radius, cut the second line from focus. Okay, don't forget, always you move the compass center. Okay, you need to change the radius 1 dash 2 dash and move while cutting. After taking the radius 2 dash, don't keep your compass at 2. Okay, move your compass to focus only. Okay, cut the second line above and below the axis. So generally the students will do mistake here only. They will take radius 2 dash, but cutting that line, while cutting that line, they keep the compass at 2 only, center keeps 2 only, and they will cut again on the same line. Again, that will lead to some other shape, not parabolic shape. Okay, or hyperbolic shape. You will get different shape. So don't forget to take your center of the compass at F all the time. Only the changes is radius 1 dash excuse me, 1 dash 2 dash 3 dash. Okay, now I hope you can able to make up, right? So after that, after getting some number of equal points or some arcs, so you can see one arc here, you get you put a small point here and here 1 point. Okay, join all the points, those we call generating points, passing through the vertex. Vertex is the starting point of the curve. Okay, now you need to take HB pencil, draw a smooth curve passing through the vertex. Okay, now this is the procedure. What we learned in the normal and tangent procedure also you can apply here. The same procedure you can apply here. You can choose any point on the hyperbola. Somewhere I have taken, right? But the next step, after taking this point, I have to join that point to focus. You will get one line here, right? And draw one perpendicular to that line from focus onto the directrix. It will meet, this perpendicular will meet the directrix here. Yeah, any question?
Sir, once can you repeat again, sir, after drawing the curve from focus? What do we
You,
do?
you need, so what you require is normal and tangent, right?
Yes, sir.
Yeah. See, first you can select any point on the, curve. For
Yes, sir.
example, I have taken this yellow color dot. You are able to see this point P?
Yes, sir. On the one dash line.
Yeah. This point you need to join to the
But then we
focus.
have to join it to the arc, na, sir.
No. You can take any point on the curve, join that point to the focus. Focus point is there, right? On the
Yes, sir.
axis. Simply join to the focus. You would get one line like this. Okay,
Yes, sir.
and match your mini drafter scale, one of the scales to this line. Okay. What happens if one of the mini drafter scale matches to this PF? Okay. Then other scale automatically shows you perpendicular. Okay. You
Yes,
need
sir.
not you need not use any protractor. That perpendicular will meet the directrix somewhere here. Okay. This per
Yes.
this perpendicular will strike the directrix somewhere here. Simply join that point to the selected point P. Okay. See, like this. This angle will be always, remember, 90 degrees. So this 90 degrees line will meet the directrix somewhere here. And remember, take any ordinary scale, join these 2 points. Okay. The intersection point on the directrix T, and you have taken already one point on the curve, capital P. Join T and P and extend further if you want. Okay. That is the tangential line. Okay. And normal and tangent mutually perpendicular to each other, right? Again, use the mini drafter again. One of the mini drafter scales you match to this tangent, other scale automatically give you the normal. That is the advantage of mini drafter. And remember, normal and tangent are 90 degrees to each other. Okay. After drawing normal and tangent, you see whether these two lines are at 90 degrees or not. Otherwise, we have done somewhere some mistake. Okay. That self check also sometimes required. Okay. Any other doubt here? Once again, I am repeating. Eccentricity is given 3 by 2. Add 3 plus 2, 5. So divide the CF length into 5 equal parts. Locate vertex moving 3 parts, that is numerator parts, 3 parts from the focus. Then take VF length, which is equal to VE. To locate E point, I am telling all these things. E point, how to get this E point? Take VF distance and draw one perpendicular so that this V length must be equal to VF. This is very, very important. Okay. Because in case of ellipse, what happened? VF is equal to only, we have left only 2 parts, right? So only 2 parts height we get. But in case of hyperbola, we are leaving 3 parts. So the V height is increased. Now this time it is 3 parts, okay? Compared to the 2 parts in case of ellipse. Now join C, extend it, take after vertex, there you can select n number of points on the axis, 1, 2, 3, 4, 5, 6, and so on. Then draw perpendiculars. Those perpendiculars will meet the C extended line at 1, 2, 3, 4, 5, 6 dashes, right? Like 1 dash, 2 dash. Okay. Now take your compass, set the radius 1, 1 dash. Okay. Focus is the your center. Cut that first line 1, 1 dash above and below. You will get 2 arcs. Okay. That means 2 generating points we have generated. Okay. Then go to 2, 2 dash radius. Focus is center. Cut the second line. In that way, you can take 6 or 7 points because it's not a closed one. Hyperbola and parabola, these two are open curves. Okay, so no need to take more number of points. Yeah. Any question here?
No, sir.
Yeah. So then take your HB pencil, join all the generated points, passing through vertex. You would get a smooth curve. You draw with a free hand only. Okay. You need to get a smooth curve like this. While drawing this curve, use HB pencil in a single stroke. You need to draw this curve. So generally, what you will do is you draw first with 2H pencil. Again, you will take HB pencil. Okay. Don't do like that. Take directly HB pencil in a single stroke. That means the thickness of the curve, okay, should be very narrow. Okay. Don't draw 2 3 times. Okay. That is the way you need to draw the use the pencils also. Thereafter, You can select any point on the curve, join that point to the focus, then you will get one line. Perpendicular to that, you draw one more line that will meet the directrix at point T. Join T and selected point P, that is going, and extend little bit, because tangent is nothing but some infinite length of line, straight line. Okay, so don't stop at P. Join, extend TP a little bit further. Okay, and at point P again you set 90 degrees line to show it as normal. Okay, to show it as normal like this. Check whether the drawn normal and tangent are 90 degrees to each other or not at the end of the problem. Okay, in this way you can able to make up the hyperbola. Is there any questions that I can explain?
No doubt.
Now can you apply the same procedure and draw the parabola on your own?
Parabola.
Yes, sir.
See,
So this time directrix should be on the other side, right, sir?
directrix.
Should be on the other side. No.
Sir, same like this hyperbola, na sir, but we need to take vertex as a midpoint between center and focus.
Yeah,
Parabola will face on
yeah,
the upside or downside, sir.
yeah, good. One thing I would like to ask you. So, what is the eccentricity of a parabola?
One, sir.
One.
So, what is the ratio you can assume?
One
1
is
is to 1, sir.
If it is 1:1, how many number of parts I have to divide?
two parts.
Two parts. Okay. So you can directly bisect it, or you can choose. You can use the line division method also. Line division method also you can do. Take any angular line, draw only two arcs, right? So,
Yes, sir.
so how to locate vertex then?
It's the midpoint
Numerator
of
part. No, numerator parts, right? What we are discussing numerator only. So numerator is only one. So from focus,
between us.
just move one part. That will give you automatically the midpoint. Okay?
Yes, sir.
Or else you can select 2:2 ratio, right?
Yes, sir.
3:3. Then follow the same procedure. Remember, what is the distance of VF? That must be equal to the distance of VE. That's it. Okay, you would get automatically the parabola. Okay,
Yes,
can you do that assignment?
Yes,
Okay,
sir.
can you give the question for the parabola, sir?
Question.
Yes,
sir.
I mean the measurements are like
No, there is,
Focus between
yeah,
left
yeah. You can say you can take the same data. Okay, nothing. So you write if you want to construct a parabola, the distance between the directrix and focus is 50 mm, and the eccentricity is equal to 1. Eccentricity is equal to 1. There is no other great data here. Okay.
Yes, sir.
Yes, sir.
So that parabola is an assignment, and hyperbola and ellipse you have to practice at home. All three problems you have to show me in the next class, and post it in Google Classroom. Already
Yes,
I have
sir.
given you some assignment. You can check that assignment. At the end of that assignment, you can see one link how to upload the submission. Okay,
Yes, sir.
so you can.
Sir, in one stage, can
Yeah,
we drop? Can we
yeah.
drop it, sir?
Yes. You can use the same chart. Okay, one single back and front side also you can use. Okay,
Yes, sir.
you do one thing. Front side you can draw hyperbola and ellipse. Okay,
Yes, sir.
at the back side of the chart, in the title block you write it is assignment problem. Okay,
Yes, sir.
uh, name it as parabola.
Okay, sir.
Okay, so while uploading you take the same photos, same photographs, write your roll number, name while taking the photo. So whenever I open that photograph, I need to see your roll number, name section. Okay,
By
like
when
that.
you will submit it, sir?
How much time you require? Actually you have to practice along with me, right?
Yes,
So
sir.
only one homework is I have given, only single problem he has given as homework, right?
Yes,
So
sir.
don't take much time. After end of the class, So by this today only you finish at home, okay? And next class, I think tomorrow, day after tomorrow, you please complete. You can submit the assignments, okay? It's not a big assignment, right? A simple assignment. So after due dates, okay, if you submit, automatically your marks will be reduced, okay? Immediately you respond. I want to see all the submissions in the Google Classroom when you come to the next class, okay? So I will set the deadlines in the Google Classroom. Those who are posting late, automatically the marks will be reduced, okay? According to the problems given to you, I will give you the deadline, okay? Single problem I have given you, you need to submit immediately, okay? So can you try to learn one more problem, that is rectangular hyperbola. It is special case of hyperbola, okay? Then we will end this particular class, okay? So I am sharing one more screen. Yeah, can you able to see the screen? Hyperbola, point B,
Yes, sir.
30 mm and 50 mm respectively from two straight lines which are at right angles to each other. Draw a rectangular hyperbola from P within 10 mm distance from the each line, okay? So he is asking, draw a rectangular hyperbola, okay? So what is the eccentricity of a regular hyperbola? Anyone?
Less than 1.
No,
Less than 1.
no, no.
Two, sir. Two, sir.
Root 2, sir. Root 2.
Greater than 1, sir.
Greater than.
Root
Greater
two.
than 1.
Yeah, I am asking regular hyperbola.
Greater than 1, sir.
Regular hyperbola less than
Great.
1.
Greater than 1, sir.
Okay, less than one. If you say you are in ellipse only, okay. I am asking hyperbola. If it is a regular one, greater than one, but it is a special one. It is asking rectangular hyperbola. It
Root
is
2,
also,
sir.
it is having
Root 2.
yeah, it is having specific value, that is root 2, okay? Root 2 means what? 1.414,
414.
that is greater than 1 only. But why it is special? Because the name says it is a rectangular hyperbola. You will draw that one, then you can see that the difference I will tell you, okay? So it is having specific value. Rectangular hyperbola having eccentricity equal to greater than 2, root 2, sorry. Root 2 means 1.414. So he has given 1 point on that curve, okay? And its distance, that point is having distance from two straight lines are given, okay? Then we need to use that point and try to draw one curve passing through that point, okay? So first of all, what we have to take is uh, you draw one vertical line and other horizontal line like this. So are you able to see the screen?
Sir.
Yeah. See, this vertical line, I call it as vertical asymptote. Okay. Horizontal OB line is there, horizontal asymptote. These two are 90 degrees to each other. Okay. Orthogonal asymptotes. This is known as orthogonal asymptotes. But coming to the regular hyperbola, this need not be 90 degrees. Okay. These two asymptotes are need not be 90 degrees to each other. But coming to rectangular hyperbola, these two lines these two lines known as asymptotes are 90 degrees to each other. Okay, that's why it's having a specific eccentricity which is equal to root 2. Okay, so remember the steps how to construct it. Okay, we will discuss further after completing this procedure. Okay, step by step. Now, here as given in the problem, this point capital P is located some distance from uh, this line and some other distance from horizontal line. Vertical line distance is given. Now we can see a point 30 from 30 mm and 50 mm respectively from two straight lines. These two straight lines I am calling as asymptotes. Okay, at right angles to each other, orthogonal asymptotes. That's why it is called rectangular hyperbola. So rectangular sides are 90 degrees to each other, right? That's why it is known to be orthogonal asymptotes. So the name comes from that rectangular hyperbola. Okay. Now here we have taken two asymptotes like this, and the point P we need to locate, right? To get this point I need to know what is x distance and y distance, right? So he has given x is some, you can see x is some 30 mm and y is from a horizontal line 50 mm. So can you locate this point P by drawing these two lines like this? 2h pencil, with help of 2h pencil, can you draw 130 mm parallel to this vertical line here? And can you draw one horizontal line parallel to this OB? So that intersection is nothing but the given point capital P. Can you do that?
Yes, sir.
Yes, sir.
Sir.
Sir, but x-axis looks like 50 mm, na, sir.
Exactly.
Okay.
Exactly. Okay.
Yes, sir.
So I have taken from the ground it is 50. I have drawn one horizontal line, and from this 30 mm, okay, I am drawing one parallel line to the vertical asymptote. So I get one intersection point, right? These two lines will meet at point capital P. Actually, this is the point given in the problem. Now with help of this point, you need to create other points, other generating points to draw hyperbola. We call it as rectangular hyperbola. Okay. Then how to get those points? That is the question. After getting this point, which is given in the problem, with help of this point and the lines we have drawn, we need to generate so many other points. For that, what we have to do is select any random points after point P like this. Similarly, above the point P, you can choose few more points. Okay, generally you can take even number of points. Above I have taken 4 even number of points. Okay, and after P also I have taken some 6 even number of points. Okay, after taking these points, okay, from the origin, the intersection of these asymptotes known to be the origin point O here, join all the points you have selected. Okay, you can also name it. I have drawn some lines. Are you able to see on the screen?
Yes, sir.
Yes, sir.
Sir,
Yes.
sir, should these points be equidistant?
Actually, need not be equidistant. Okay, if you want to take equidistant also, nothing wrong. These are some random points only. The distance between these two, okay, need not be same, not required. Okay, you can take equidistant points also. So from origin point, what I have done, I have joined all the points I have taken. So after that, what you have to see is these lines are intersecting this particular vertical line at some different points. You need to identify carefully here. I will show you. So you see this first point after P on the horizontal line, after P you can see one point here. If you join that point to the origin point, this particular inclined line will meet this particular vertical line somewhere. You need to identify that point. Okay. Now then whenever it is wherever it is hitting this line, you note down that point, you draw one horizontal line and one vertical line from the point here. Okay, those two lines will meet at this point. Okay, that is the first generating point. In this way you can do for all the lines. Okay, from all the points you can get so many generating points. You can join with freehand, passing through these generating points. You can get the required rectangular hyperbola. Okay. Then I will show you one more point. You see, the second point, if you join to the origin point, right, that line will hit this particular line at this point. From there, I have to draw horizontal line, and from the second point, you need to draw the vertical line. That is going to be your second generating point. So in this way, you need to generate the so many number of points. Join with the freehand with HB pencil. Okay, that is the procedure. Now the third one. So third line, third angular line from passing through this third point and origin point. Okay, it will meet the at this particular location. Then you need to draw one horizontal line and vertical line. And fourth point, one vertical line and one horizontal line. So in this way, you can see the. Then I got 1, 2, 3, 4, 5, 6 points, right? So you can join with freehand using HB pencil. Okay. Similarly, I have taken a few more points above the point P also, right? 1, 2, 3, 4, right? So again, same procedure. Join that point to origin, join that point to the origin, second, third point also to the origin, fourth point also to the origin. So these lines will meet horizontal left hand side of the point P. There is a horizontal line also, right? That we so that horizontal line is cut by these inclined lines at different points. So what you have to do is you need to draw vertical lines whenever it is intersecting horizontal line, vertical line, and from the dot you need to draw horizontal line like this. So you can see there is four more points, 1, 2, 3, 4. So passing through all these points, you can able to join the curve. Okay, that is known to be the rectangular hyperbola. So in your syllabus, only rectangular hyperbola, normal hyperbola, parabola, and ellipse. These four figures are given. So I think these are sufficient for your practice as far as conic sections are concerned. Okay. In the next class, we will see cycloidal curves. Again, in the cycloidal curves, we will have cycloid, epicycloid, hypocycloid. Okay, and we need to complete one more topic in the unit number 1, that is engineering scales, plane scale, diagonal scale, and vernier scale, something like that. That we will see maybe in the next few classes. Okay, so this is the important problem in the conic sections. So in the conic section, total how many problems are there? Total, including this rectangular hyperbola, only 4 problems. I have given you one assignment, okay, one homework. So, and this is also is a homework for you, okay. You complete this one also. So that we can finish up these conic sections, okay. So any questions in this particular
No, sir.
figure?
No, sir.
Here you remember, you may have a doubt here. Here you see vertical line and horizontal lines. Okay, so you see here horizontal lines above the point P and below the point P is always horizontal, parallel to each other. Okay, and wherever you are drawing vertical lines from points, right here, these are vertical lines. So above point P also there are vertical lines. Okay, these vertical lines and these vertical lines are parallel. So use the mini drafter very carefully, and always try to use the mini drafter, so that whenever you see vertical lines are there, whether all the vertical lines should be parallel to each other, Whenever you draw horizontal lines, you need to draw the horizontal lines parallel to each other all the time. Okay. While holding the mini drafter, hold the mini drafter knob. Okay. Don't hold the scales. Okay. That will uh, 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 disturb the lines, horizontal lines. That some error will come. Okay. Yeah. So any doubts in this?
No, sir.
Okay. Now, so we are having 7 more minutes. Just I would like to brief. Okay, conic sections, and please wait. I would like to share one screen. So are you able to see the screen?
No, sir.
No. Okay. Wait. Yeah. Wait for a minute. Are you able to see the screen?
Yes, sir.
Yes, sir.
Okay. Yeah. You can see here the conic sections. Actually, there is a right circular cone. If you cut that cone at different angles, right, we are generating different sections. One is ellipse like this. Okay. One is an ellipse like this. Okay. Are you able to understand 3D picture here? What I'm
Yes,
showing?
sir.
Yeah. So here you see there is a line, oh, cutting line. Okay. If you cut the cone and remove the upper portion, okay, at the cutting zone, the section created is known as an ellipse. Okay. Again, you can see here you see parallel to the one of the triangle side. Okay, we call it a generator. If you cut parallel to that one, again we are getting one more conical section that we call it as parabola or hyperbola. This one, anybody?
Parabola. Parabola.
Very good. Now, if you take again the right circular cone, if you cut parallel to the axis, okay, not passing through the apex, but parallel to the axis, and if you remove the left hand side portion, the section created is known as hyperbola like this. Okay. And I will ask you one question. It is something like interview question. Okay. If you take cutting section passing through the apex point, you know this is the vertex point or apex point of the triangle, right? If it passes this cutting line passes through this axis, there is no gap here. Okay. Then what is the section that is created?
Rectangular
Triangle.
hyperbola, maybe.
Triangle, sir.
Rectangle, circle. What is the right option?
Triangle.
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 Very
Triangles.
good. Very good.
Triangle, sir.
Yeah.
Triangle.
That. Yeah. Recently in the NPTEL exam, that is the question given. The answer is triangle. Okay. The answer is triangle. So sections of solids, there is a topic in your syllabus in the unit number 4. Okay, wait for that time. You need to learn some other sections. Okay, some other. We need to draw sectional views. Okay, front view, top view, and side view. If you cut a particular cone at an angle, okay, if you remove one portion, if you see its top view and front view and the side view, how they looks like. Okay, so those things we will discuss in unit number 4. Okay, so as part of introduction to the conic sections, I think this is sufficient uh, data required for you to understand the concept. Okay, and we have discussed ellipse eccentricity less than 1, parabola is equal to 1, hyperbola greater than 1. As a special case, rectangular hyperbola is having eccentricity equal to root 2, 1.414. Okay.
Yes.
Yeah. This is actually today we have discussed one more time. Just I am repeating. There are so many methods, procedures. Take any procedure or method, same. I have explained it differently, but output is same. Okay. You can also select points from point below the capital P and left hand side of the capital P like this also. Both are same. If you do this also, you will get the same solution. Earlier I have taken to the right hand side of P, I have taken 1, 2, 3, 4, 5, 6 points, right? So here also you can able to see that particular point we have joined to the origin, right? Here also I am doing the same. But this time I have taken initially 1, 2, 3, 4 on this line and extending that line further. Those will meet the horizontal line somewhere. Again, from 1, 2, 3, 4, you need to draw vertical lines. Okay. And you need to draw one more horizontal lines. Okay. From the corresponding points like this. Which is easier? Whatever I am showing you now is easy to understand. Actually, both are same. Whatever you feel, you can adopt that method. But at the end of the problem, you don't find any difference. Okay. Is it clear? Okay.
Yes, sir.
Yeah. Once again, watch this video at the end of the class. Okay. You can find, even though left hand side, the procedure is also listed. You need not write anything. This procedural steps on the drawing sheet. Don't write anything. Theory part. Only this figure you need to draw on the diagram. Okay. And don't forget to use HB pencil for writing letters and numbers. Okay. And anyway, for asymptotes, you can use HB pencil. And the curve, hyperbola, rectangular hyperbola, you can use HB pencil. But other lines, you need to use 2H pencil only, or H pencil. Okay. The difference between H and 2H HB is light and dark. Okay. You need to show that difference. Otherwise, there is no use of using different grades of pencil. Okay. So once again, we will, if you see any standard textbook, you will find so many methods, okay, for drawing parabola, hyperbola, and all. But don't get confused. Your syllabus is having only a focus directrix method, what we have discussed, okay. Those are sufficient for your understanding. So with this, I would like to conclude my session. Any other questions?
No, sir, one question. For X and Y axis, we have to use HB pencil. For drawing ellipse, we have to use HB pencil, and others all 2B pencil.
2H, not 2B.
Yes, sir.
Yeah, correct.
Okay, sir.
Any other questions?
No, sir.
So when do we need